In 2000, the Concorde crashed, and with it, one of the greatest feats in French and British engineering exploded. Why am I talking about a plane that crashed over 2 decades ago? That's what could happen with your app, and sometimes our apps are as complex as the Concorde. To write tests, we had an old way of doing things. Let's take this random enum I wrote, and that doesn't really match any business logic you'll have, but unfortunately, it's all I can do because I can't use production code, obviously. So basically, we have a simple enum that is plain with a bunch of cases for different types of planes. And we have a computed property called isSafe, which returns a Boolean just to say whether it's safe or not to fly on these. And historically, to test this, we would have had to use XCT assertions all over the place. And there's like a bazillion of them we had to know. So there was XCT unwrap, XCT assert nil, XCT assert not nil, XCT assert equal, and all that stuff. If we had to, God help us all, test asynchronous code, we had to write some random expectations and await the fulfillment of await until the expectation was fulfilled. Although in preparing this talk, Ellen told me that XCTest now supports this, which is really cool. Also, there was no granularity when organizing tests, meaning you would write XCT test case and structure your test plans, but you couldn't have horizontal links between them, and you really could not really create subcases and subtests. So our amazing friends at Apple decided that they were going to throw XCTest under the bus, which in all fairness is probably a good idea. And they came up with this thing called Swift testing. You may have heard of it. It was one of the big announcements, not this year's dub, the year before. This is what the new version of testing and writing tests looks like. There's several things of note here, so we're going to stay on this slide for a while. Firstly, you're going to import testing. Duh. Keep in mind that in order to be able to import testing, you have to have a certain version of Xcode. I think it's Xcode 16, but don't quote me on that one. You then need to declare, well, you don't even need to declare an add suite for that to work. All you need to do is mark a test with the @test macro. This tells testing that this function is a test function, and it will allow you to write expectations. So expectations are a XCT assert equal on steroids, and they're a macro. So they essentially allow you to compress all of the confusing and varied XCT assertions into one single clear line of code that you can understand properly. And as you can see, I have one test for the Concorde, one test for the Boeing plane. So this looks like the CIA publishing documents and obscuring half of it because I expanded the expect assertion on production code I have at work, and so I didn't want to show you a bunch of stuff. But essentially, what it does is it gets the different properties, and it does makes a bunch of assertions. A really cool feature of expect is that it will tell you not just what, so it'll tell you whether it succeeded or failed, duh. And then if it failed, it will tell you what it actually got, which is a huge indicator when you're writing tests to know what exactly you ended up with. And this can help you catch bugs and understand, maybe there's an issue with the way you wrote the test. Maybe there's an issue with the way you wrote the code. And so what's another really powerful feature of this new testing framework is traits. Traits allow us to customize the behavior of tests. So for example, if we take my previous test suite, I can now add a 1-minute time limit because I want to be conscientious with my credits, or I can disable a test entirely. There's a whole bunch of other things I can do. I can serialize tests, more on that later. I can add a bug trait to point a specific test to a bug. I can disable a test, I can disable with comment, I can disable it conditionally. I can also enable it same way. I can add a time limit, and I can add tags. Tags are essentially your way of earmarking a test. So yeah, sorry. By default, tests run in parallel, but you can opt out of that. So essentially, the tests run concurrently, which is really helpful for your CI time. But you can opt out of that by just sticking the @serialized trait on your test suite, and it will run one after the other. I don't recommend that. Usually, if you have to do that, is that there's some kind of issue, either with the way you've written the code or with the way you've written the tests. But whatever the case, you should definitely avoid that if possible. And so, as this image shows, we can really create our own custom traits and tags. So, we use tags to categorize different tests. So by doing that, we just import the testing framework, extend the tag type, and use the add tag macro. Super important here, the static var thing, it cannot be a static let, because of what the macro does a bunch of stuff with it. Unfortunately, this is a lightning talk, so I won't dive into the finer intricacies of that. And to be perfectly honest, I have no idea what the add tag macro does, but I encourage you all to check it out. And so once I've declared those tags, I'm gonna want to use it to categorize all the tests that are used to test French planes and all the tests that are used to test American planes. And this will allow me in the newer versions of Xcode to actually just run the tests of one particular tag. So if I know that I've if I've written codes to change the French planes, I can only run the code on the French using the French plane tag. And so as you can see, I can add to the add test macro a tag. Super important here. Traits, can go on the suite or the add test. So if I wanted to tag an entire suite as the suite for French planes, I could have done that too. And so this is what it would look like if I wanted to create a new trait, a custom trait myself. So as you can see, this is extremely basic, but I just wanted you to show you, what sort of code we would be looking at here. So you would have a struct. I'm guessing you can make it an enum or a class. I just went with struct. And you make it conform to the suite trait and test trait protocols. You may want to start off just with test trait if you just want to create a test trait, but anyway. And then you can extend traits and basically say that this function can only be called when the conforming type is the concrete implementation random trait. And this will allow you to customize the behavior of your test suites. And then another super important revolution that was introduced by Swift testing is parameterized testing. Parameterized testing is super powerful. It essentially allows you. So I don't know if you have this experience, but when I would write XCTest, I would spend a lot of time cramming in like a dozen different tests with the exact same logic, just passing in different inputs. And so one super powerful feature now is you can pass all the arguments that you expect the same input for into the test. The testing will automatically create one test per argument. If you provide several parameters, it will test every single possible combination, so it will save you a lot of time. And so Swift testing makes testing asynchronous code a breeze. And unfortunately, I've run out of time, but basically, before I get hauled off stage by security, I just want to say there's one caveat with adopting Swift testing that you need to be aware of, and that is that when you can't really write performance or UI tests, so and it's really not recommended to mix XCTest and Swift testing. Don't do that. And so basically, you have to be conscientious and aware of that when you're adopting Swift testing. Um, and basically, the goal of all of this is that your application doesn't end up like the Concorde. Okay, thank you all so much for listening to me. And
I think I've got a couple of questions around just sort of like what you can do with the tags, because that seems like a really, really powerful feature.
super powerful.
Is it possible to like set up a tag where, like if you have things that aren't supposed to run in a certain environment, you can just like skip everything on that tag?
So you do that with traits and
Okay.
with enabled if, and so you would conditionally, you would, I've never done this to be super frank, but I think you'd run the tests and and you just flip the boolean depending on whether or not you want that test to run in a certain environment or in a certain case. I think what tags does is you can earmark, for example, all your snapshot tests. And for example, if you've done UI work, you can run all the snapshot tests in one go and just see what amazing explosions happen when when you run those tests. So yeah, both traits to conditionally enable, disable, and do that stuff are super important, and also tags to run only certain particular tests.
Nice. So you talked a little bit about the fact that the expectations or the expect macro will give you a little bit more detail
Mm,
when you're sort of comparing like why something's failing.
mm.
Can you talk a little bit about sort of like what some of the advantages of that are over the way that XCTest does that, where it's like what is better about it?
So, at least my experience using XCTest is that you essentially had to put a breakpoint right before the assertion and like look at, okay, I was expecting this result, but this is the one I actually got. In the case of Swift testing, it when it goes red, first of all, I'm like, oh no, why me? Why again? And then you can get like the actual output that you got. And so that's super helpful because you're like, okay, if I got this output for this input, maybe there's something that went wrong in the function. Maybe, it happens also that you haven't written the testing code properly. That can happen too. So it helps. It's hugely helpful when debugging tests or even just your application.
Nice. Awesome. One thing, just I haven't used Swift testing that extensively, so I'm wondering, what's the way that is there like a similar thing to like throwing an XCT skip error, where you want to say like, yeah, if this condition fails, just like mark the test as skipped and bail out here.
Yeah, it's same thing. Traits with conditional disable, and you can add a comment.
Cool.
I think also I believe they have a closure. I've never used this, by the way, but with known error, which is
Mm,
when you have something that you know is going to fail, you can mark it with known error. But when I watch the dub videos, which by the way are like the most important thing you should look at before getting into this, they were using it if there was only part of a test that was failing.
mm.
Then again, if you've got part of your test that's failing and another part that's not, maybe you should split that into two tests.
It's a
It's
very good point.
as we say in French, les goûts et les couleurs. Um,
Qu'est-ce que c'est en anglais?
um, personal opinion. I'm very obsessed with things being as small as and s- uh, s- you know just doing one thing very well. So I try to make it so that my tests really just do one expectation. Um,
Cool.
yeah,
Awesome.
yeah.
That's my
Yeah, we have a couple of questions about the fact that XCTest had a nice expectation mechanism to test asynchronous code, that could let you do some very cool things, like for example, detecting memory leaks, or that delegate method is eventually called. Do you know if Swift testing has something similar, or if it's a use case where we should maybe more think about mixing Swift testing for what it's good at and keep using XCTest for what
Yeah.
it's still better at?
So yeah. So for the record, I don't think there's a super strong argument to like go back to all your old XCT test and just refactor or transition to Swift testing. It's just I think the new tests most of the time I mean 99% of the time there's a case for making them with Swift testing. To be honest, we don't use the delegate pattern a lot anymore, so I'm not exactly familiar with that what use case that person was referring to. What I really like with Civ testing, and as Ellen pointing out when we were preparing this talk, you can do the same thing now with XCTest, but essentially you await the results of calling that asynchronous function. And I think, of course, your test has to be marked async, obviously. Um, but I think that's hugely powerful because instead of the burden being on you to fulfill some random expectation, instead you're just saying, okay, I'm awaiting the result of the return of this caller. And so once it's returned, I can do a bunch of assertions on stuff that has supposed to have happened from calling that asynchronous function. Um, but here we're talking we're going into some deep waters, and I know I'm standing between people and lunch, but it's more about like architecture and sort of how you pick the best tool for architecture for depending on your architecture and your code, and how to best ensure that your app is working as you expect it to, and that it's working properly. So that's like my 2 cents on that.
Cool.
Thank you.
Yeah, thank you guys so much for picking me, and thank you so much to Eric, who's standing in the crowd and was the guy who trained me for a lot of this stuff. So thank you
All
so much,
right.
guys.
Bye, Emma.
Thank you.